I will speak in English. Yeah, in simple English. Very simple English. So, okay, it's time. So I will introduce myself first. My name is Sirawat. So I'm from a company called XC7 Experiments. It's only me in this company. So everyone left and find good life. So I changed my position from CEO to creator because CEO doesn't make sense when it's only me. Okay. First, this talk will be about audio latency on Android. Anyone here who has experience with latency on Android, it is very bad. If you notice, it is very, really bad. But first of all, before I begin this talk, I will just show you the severity of this problem with my webcam. Okay. Okay. First, I will show you one game that does not have anything to do with audio. I hope you can. No. Don't. Did you notice something wrong with this game? It looks fine because the sound that is playing is not related to the gameplay. Okay. Actually, those button sound is a reaction sound because it plays when you interact with the screen. But that reaction sound is not important, so you notice nothing wrong. But what if I show you this project? So this project, when I press this orange button, it will play audio with Unity. Just audio source.play with best latency. So you have to listen to my nail sound. You can see it is extremely slow. So, but in the panel, in the big panel, I have skipped Unity and just asked Android to play audio for me. No, I have to load first. Compared to this one. Well, it's much better when I skip Unity. So I also got something else for you, like the iOS. You cannot see, right? Okay. This is also Unity game, but on iOS, which I will not talk about it here, but similar problem. Here. Right. It's pretty good on iOS. But even better if we skip Unity. No. Sorry. Compared to this one. It's only a little bit of difference, but still count. So the question is why? Where is that time that increased so much for the Android? I want to talk about it today, so you know what's happening. What's really happening? I forgot to connect this one, sorry. because the okay. So the Android I test for you earlier, I recorded my nail sound and the response sound. look at the difference. It's so much different. So when I skip Unity, I gain all that latency back. So that small latency is the Android audio latency, the pure Android audio latency. So today we will know exactly what is that difference. As you can see, the slow audio is just this. So event trigger when I touch the screen, and then just play. And this is the best latency I can do. I cannot do better with Unity. It's the best. The best. Okay. Also, you have to account for the time to take from your finger to the input, but that's for everything. So well, maybe it doesn't count. But also, this way is the fastest way to get input in Unity currently without hacking. Okay, we will know exactly what is that time. First of all, I will introduce you to some numbers. As you can see, nothing can be free of latency, like 0 milliseconds is impossible. Like if I do this, still there is some latency of sound traveling here, like 300 meters per second or something for the sound. When you're singing, the latency is very low because it goes through your head, through your bones, and to your ear. So that's why you can hear yourself. And and when you use like a microphone, that goes to some effects. When you are making music with your vocalist, for example, if the effect chain is a little bit longer, then the vocalist will complain. It doesn't feel natural at all, because the natural latency for vocal is very low. So you need this extreme latency. But for drummers, well, because it is in front of you, when you hit the drum, it goes right here, but still a little bit slower than vocals. For guitars, maybe you put some effects if it is an electric guitar. So it takes a little bit of time. But the nature of guitar is that, well, there are many sounds coming from all the strings, so it's kind of okay to get this latency. It all blends together. For keyboard, you got a voice chamber, so it goes through the voice chamber and then reflect many times and go back to our ears. So it's quite natural to get about 20 millisecond latency from keyboard. I mean the real piano. If you bought a MIDI keyboard, that is no sound, but computer will play sound for you. To feel realistic, so the designer have to beat this latency or get close to this one, which in Mac OS is doing pretty well because the audio driver is very fast, the core audio. Also, there is some other number like simple reaction time. You do something to a person and then how long it takes to react to that. By age, you can see at age 24, it takes about SRT. You see it's about 200 milliseconds, I guess. So when you get older, it increases, but not much. So one other number to take in account is 200 milliseconds. It's 10 times the keyboard latency is for you to react. Also, there are kind of many written games will require you to hit to the perfect judgment, but each game has different perfect timing you have to do. So some numbers here. Actually, many games use like about 40 milliseconds. Why is that? Because in some game it is tied to the frame rate, so it is a multiply of 16, because that one divided by 60, you get 16 milliseconds. So it is some multiply of that, a number of frames. For arcade game, maybe you get 120 frames per second, so granularity is much better. For one game, is the dance game called DDR. It's very small. It is currently the smallest in any game. It is a big feat if you can hit marvelous in the DDR. So my point is, this small number, even lower even lower than piano is significant, because there is someone who can consistently do this time in this small number, so you have to care. Actually, I got a clip for you. If it plays, I will try. Okay, it plays. Everything is in that timing window. So that marvelous is in 15 milliseconds. So this time it's so small, I don't know what's happening. I don't know when I get marvelous or perfect. I cannot discern anymore. But I have been playing music games for like 10 years, but I still cannot discern perfect from marvelous. I don't know what's happening. But great, when I get great, I know, that's late, or that's early, I get great. But someone can do it. You have to care about time this small. And let's compare with this time. The 250 milliseconds is much higher than that window. Imagine the DDR player that come to play your game. He will complain. Okay, that's why you should care. I just said it. So before fixing this problem, I want to introduce you to some kind of game that relies on audio. So this is all made up. I put some category on them. So an app that works like a sequencer. Latency does not matter. A sequencer, the most basic sequencer is your music player, like Winamp or iTunes that play music. So when you press play, it plays, but maybe it takes some time to load the audio, but you doesn't care, you want to listen to the music. It does not matter at all, it loads like 2 seconds, it doesn't matter. Also not just music player, also the real sequencer like digital audio workstation. Even though you can sync something, but the program can compensate because it knows when to sync. It does not matter if it starts a little bit slow. All it matters is that it is on sync. Everything is on sync, it's okay. It does not matter at all. But the second class is instrument, like GarageBand or some synthesizer. This one, it will affect the user's experience because you press and it takes some time. It's not like the real thing. It's not like the real piano at all. But it is impossible to be zero, I know. But it can be compensated by the user because when you jam this one with some bands or with your friend, you can adapt. It is like the real instrument. Each instrument, like if you are playing guitar, if you play guitar so much, you will start compensating that small latency by yourself. Yeah, if you are a vocalist, then you will sing perfectly. If you are a keyboard player, then maybe you will naturally compensate. So in this kind of app, maybe user can take care of that latency by themselves. But still, it is better if it just plays sound quickly, but the user can fix it. But the most difficult class is the rhythm game because there is a backing track. That's the big problem because if everything you press will play back a sound, if you press exactly to the backing track, you get perfect, but the sound will be delayed, of course, by 200 milliseconds, I show you. But when you do that, your ear will hear that the sound is not right, but I'm getting perfect anyways. So in the next hit, you are trying to get the sound right, but now you get bad or great, you're not getting any more perfect, but the sounds right. So the game can compensate the track to move later in time, but still the feedback sound will will be error because it has to wait for your input. You cannot predict that the feedback sound has to play earlier than you press the screen, unless you are magician, or maybe you use neural network to predict that player will press, then you can play early. But I don't believe you can do that. So there are some music games with feedback sounds. If the game has no feedback sound, then it is reasonable to just compensate, to just move the audio later in time. Okay. But with feedback sound, this problem is very difficult because either you have to press early and get perfect sound, because the game intentionally moved the perfect timing early, so the player will have to also press early, and the feedback sound match. Well, but it is very unnatural. But still, this player will ingrain in their memory that you have to press a bit early because it is impossible to press and hear the sound right now. Okay, so you now understand that the lower the latency, the better, of course, for this kind of game, if you try to put the feedback sound in your game. Okay, so now let's focus on the Android, because the latency number is very bad. Each device also actually prefer something. Not all device is the same, as you know. In Android is not really. No one is really happy to deal with millions of devices of Android. But about audio only, not counting screen size or CPU. Each device wants to work with some kind of sample rate of audio. So maybe this phone wants to work with 4800, 1000. But some older phone maybe not the same. Also, there are two flags, that is low latency and pro audio. You can ask for the phone from the phone. There's an API to ask from the phone, but you need Jelly Bean or Letter. And to ask the flag, you need that one is maybe Marshmallow, I think. But this flag, it is set by the manufacturer. So if the manufacturer forgot to set it, then you don't know. Maybe someone can set the flag without even qualify for this latency. So if you got low latency audio, maybe it has to be less than 45. But pro audio, you need a round trip of even smaller than 20. Round trip mean maybe you will use your mobile phone as a microphone for making music. So that's the meaning of pro. But for sure, you can ask for the native sampling rate and optimal buffer size, which I will talk about it today. An example is that, you got like 4 stats for each phone, sampling rate and buffer size, and then boolean, like that. You can try to go to the web superpower.com/latency. This web has a calibrate app, so if you just press one button and it will say what the power level of your phone. But also the app will collect your data and then put on the table, very big table in this page. So maybe you can just search for your phone model and you will find someone already do it for you. So next, I will explain if Unity does not exist, if you are just an Android developer, what you have to do to make the sound come out of your phone and get that latency I show you. So this is an overview of audio API in Android. So the yellow box is in Java, but the purple box is in C++. So this one is all the class name in yellow, class name in Java. Note that there are 2 audio tracks with the same name, but one is in C++ and one in Java. So I will say clearly which one when I talk about audio track. About this API level, Actually, Android developer will not use that one. It is very unfriendly. If you do something wrong, then explode everything other. Like OpenSSL is an open standard that maps to something. So Google do something so that it maps to this method in Android. But if you want, you can also use this audio track without help from OpenSSLES. The name might remind you of OpenGL. It works like kind of like the same. You do things in step, and it remembers something, and you do things, and you take everything, and then error crash. You see not in OpenGL, you see nothing. In here, you hear nothing. Okay, so you now know that no matter what you do, even Unity team, no matter what the team do, it must become this one. So we will start from this one, so you know what's happening above that produce this. So I will start from audio track in C++. So this one, the audio track will, this class, if you instantiate, if you new this one, you will get a track. It is this square I draw here. It's one track. One track has to be in a thread. I believe I put some bigger image. Okay, I remember now. If you start up Unity and then you do ADB logcat, you will see something. If you try to look, you will see something. It's a audio track set and then some parentheses. So this is C++. It put this kind of parameters in the directly in this one. So Unity probably do something, and then it calls this one new. But I want to point you to something here. You see, some of this number is really strange. Why this number? To 24,000? It is not any of my phone sampling rate. No, the number seems very, just random. So I will tell you later. Also, frame count, this is very large, but not matching any of my phone also. So it goes to this function in audiotrack.cpp.c++. So you notice this big parameter list. It actually comes from that one. You see, every number all come to this one. And then this set you see a log. So this goes directly to your debug logcat. Yeah. And then right here it will do switch case and if, and then you get slow. That's why you get very slow when Unity do something wrong here. It do something, and then you get slow track. So the track, you have to know what the track can do. So what it wants to do, it wants an audio stream. One audio stream is like a series number. In the audio file, it is actually how the speaker vibrates, because when the speaker vibrates with this number, and then your ear will vibrate at the same frequency and same amplitude, and then you hear things. So one track wants exactly one audio stream. You might be wondering how can you just have like footstep sound in Unity and music in Unity, and then any other magic sound and ambient sound in Unity is a different audio track, audio stream. So to fit the track, you have to do something and make it only one track, so the track can play. So you will notice that there are two colors of the box I draw. There is a thing called fast track actually, but you guess it, Unity will make you a normal track. So that's why you get the latency. That's all. But the fast track has a very strict requirement. So you have to say to that set to that instantiate method that the sample rate must match what your phone wants, and also buffer size also must match. And even more, there is a limited number of fast track you can have in the whole phone. If someone else already taken your fast track, then you will still get normal track, even though you have qualified for all other requirements. So this phone, when I do this correctly, like I put this number into the sample rate, and then I put this optimal buffer size, then I will get a fast track. But if I have this Unity game, multiple instances of this Unity game open like 10 Unity games, and then I open more, maybe I get normal track because all fast track has been taken. How it works is that it is fixed at 7. Only 7 fast track. This, notice that we are talking about mixer thread, which is this gray box. So the fast mixer can hold up to 7 fast tracks, and also 7 fast track is shared by the whole phone. But if you count the normal tracks also, you can go up to 32 tracks. And in the fast track, you cannot resample. So about the sampling rate, maybe someone is not familiar with this term. But what if I say hello, and then you want to keep this word somehow, you want to save it? Actually, even the entire Amazon AWS cannot hold it, because my hello is very, very high definition. Maybe you have to sample every little detail. In photographic term, maybe it is like pixel. If I look at my finger, I can look however close, and I cannot see any pixels. But when you take picture, then you can see, it's not real. You see some pixels. So a sample rate is needed because you say how often you will take some sample. So you can keep my hello. Okay. And imagine if I say very high number of sample rate, so I take so many samples. But the track does not use the correct sample rate. The track say it wants to work with lower sample rate. The track is going to read the audio at some certain speed. But because I have so much data, then the read speed, then the audio becomes slow like horror movie. Yeah. And then if in the reverse, then the audio is like chipmunk. So the track will try to read much faster, but the data is not that much. The audio will be pitched up if it doesn't match. And that is what's happening with the fast mixer. But if you got normal mixer, then it can resample. So even if you got the wrong sampling rate, it will try to resample your audio. Maybe it will make up new data so that it matches with the read speed of the track, and then you hear my hello perfectly, even if I sample it a bit too much or too low. So that's the limitation of fast track. I just talked about this without showing the slide, sorry. So imagine in the first one, you sample in that rate, but the track is going to play in this rate. It is going to read very fast. So that data will run out sooner than intended. So the sound will be chipmunk. You can imagine that. It pitched up and very fast it's ended. And maybe crash because you read into now buffer if you program your OpenSSL incorrectly. In the create track, I have dig into the code. Actually, to get the fast track, you have to input some track fast. And then there are multiple if to say that if your track is not that, you will not get fast. And when you run out of fast audio, then you will not get fast. So if you use Unity, probably it will fail. You will get normal track. There's this command I want to introduce. If you run this in your ADB while connecting your Android to the computer. It will dump your latest audio status. Like if you just play the audio and then quickly press this command, it will be different than if you press it later. It's very real time. I want you to see something here. I made a Unity game that requests audio track additionally from Unity. You can see that this number, this high number, is all the same. It is saying that it is all coming from my game. But what about this one? This one means it is from the phone. Your phone is already using a fast track before your game. Your phone has already taken one fast track. And I get 6 more. And then this one is not fast, it's normal. And if I miss this one, I say a different number, then every F will disappear. I have to get it right. But your phone will have fast track, mostly. Notice that this is mixer thread, the gray box I showed you earlier. So I think I got it in the next slide. Okay. When Unity say this, Unity will get normal track for sure because it is not matching with the fast track criteria. Let's see, when I start a new vanilla Unity game with nothing at all, just blue, cornflower blue screen. You can see that this thread has your phone. F means fast. And then this one is definitely your phone because you just debug this number. This one says fast. Fast is good. I like fasting. And then this one says fast mixer thread. Everything says fast, but the only track on this thread is your phone. Where is your game? Actually, it is in another thread. This thread is very bad because you see the buffer size is 10 times of the fast thread. And this one even say deep buffer. The meaning of deep buffer is that it is for power saving. It plays your audio very slow, slower than slow, to save power. And Unity managed to get the track into this thread. It's very bad. So this is definitely Unity because the PID number is high, no F, no fast track, and this mysterious number appears here. You can see on the Unity startup this number. So this is why your Unity audio is very slow. Let me check the time. Okay. But how can Unity do concurrent sound? You can play many sounds in Unity and it comes out fine. But you see Unity only got one track. Remember that one track will want only one stream, one audio stream. The answer is mixer. Actually, Unity already got Fmod mixer. If you have worked with Fmod or WWise, you might know that it can manage your whole audio collection and then make some preset, and then you can play it in a loop that you program or something. But Unity already got a part of Fmod inside. You can still use Fmod again, but that's not what I want to talk about. This Fmod will mix your sound into one audio stream. And imagine this. Before I go ahead, this one is the number of sound you can play simultaneously. If you play something more than this, Unity will just choose the loudest one to mix because maybe it's too much if you have 1 million sound and you mix everything. So you have to clamp something out. You have to imagine if I play multiple sounds. To make it into one audio stream, then you must wait and mix. So the first latency from Unity is Unity have to wait until the end of frame. Imagine that you got 4 mono behavior and each one play audio. You cannot just play right here at the mono behavior. You have to wait for everything and then collect. And then you get one slice. Right now it must be this combination of sound add together and then send to the track because the track can only accept one stream. And Unity already has a policy that allocate only one stream. So the only way is to mix. But if I do it in native way, I can just add a new track, like I can add 3 tracks for those 3 sounds, you see. And then I say this one play right now into track number 1, this one track number 2, this one track number 3. I already gain some latency because I can play the sound mid-frame. I don't have to wait. Also, I don't have to mix. So that's 2 latency I mentioned. Also, Unity also have another layer of mixer. Unity can apply effects and send to bus in Unity 5. They introduced the mixer screen. This is also latency before Fmod can mix your audio to one stream. So if I use native, then I gain this latency back. So that's the 200 number you see. That is not all 200 number. Also this one, normal track. If Unity get fast track here, then I can still gain something more by skipping mixer and skipping all the Unity utility right here. So even if Unity choose perfectly fine audio track, then we can still get more by playing mid-frame with our mixer. But then there is a problem on concurrent sound. You cannot play something concurrently without mixing. So maybe you have to ask for a track equals to concurrent sound you want to play, maybe 3 or 4. So it does not go over 7. Okay, but you cannot ask for 100 because the limit is 32 and the game will crash. Okay, this is how the flow goes. You have, at the importer, you can also already resample your audio to something you like. You can put any number. Does not care about your phone. But then they have to resample to this mysterious number anyways. So that resample at the importer can save your game space, but it will have to resample to this number again. Because this number comes from nowhere, I have no idea why it must be this number. But actually some phone can go to OpenSSL and get the correct instantiation and get fast track. So you only pay for mixing. But in some phone like the one I show you, this one go to Java and get the sampling rate of 24,000 and then get slow track and then get everything wrong. Why? Why doesn't Unity do this always? Because I have talked with Unity team in the forum. He say it is very safe to do that. So he say there are millions of phones, and if we do OpenSSL everything, then many, especially Chinese phones, will fail. So there are some criteria that if you fail to be qualified for that, Unity will use Java for safety, just for safety. And that number is also for safety, he say. But it makes your sounds slow. Yep, so I have said it. If you use OpenSSL, finally it will just go to set of that audio track anyways. The code that translates OpenSSL to Android audio track is called ProjectViewAudio, and you can just clone and then look at it. But some example here, you will see a variable called blacklist. So if you got any equalizer or bass boost or some resampling or some virtualizer, then immediately you will get normal track from OpenSSL. Because if OpenSSL let you do this, then it will error at audio track anyway. So that's how the wrapper works. So in Java you can, it is like C#, you can new things. When you new one audio track, you get exactly one track, nothing more. Yeah, now you know why the class name is the same, because one instance is exactly one track. If you put a for loop like 33, then the game will crash because the limit is 32. One track per one sample. And still you have to set something so that you get fast track. But anything after that point is the same. You can ask this track to play one stream. By asking this instance, you just instantiate. You cannot just instantiate every time you play a sound because it will fill up your track and then crash. Next one, I will not talk about it much because it is much higher level. In sound pool, you do not get a track from instantiate sound pool, but it will manage your track intelligently. So when you want to play something, you can even put an audio file in it. It does not accept audio stream, it just wants a file. Very convenient, and you can use OGG, and then you can just ask it to play, and it will think that you need one more track to play this one concurrently with that one. So yeah, here's your new track. If the track runs out, you can put some priority in some track so that it cuts off this track, and then it does not do that. So sample is higher level, and usually Android developer will use this one because it can load your collection of sound in a pool. So ideal for games. In audio track, you have to hold your audio somewhere in byte array somehow, and you cannot mix. In sound pool, it uses the track to mix for you. And lastly, media player is for playing music or something. You cannot get fast track with media player, but it can also play videos and something more. I forgot. Sound pool, you can also pause and then set looping and then many more. You can resample also. You can play the audio faster intentionally. When you know you have a limited number of audio tracks, I can intentionally crash Unity. Because I made a game that requires 32 tracks, and then I start Unity game one more. What will happen? So audio says something strange. Unity says something strange. Yeah. So it say fmod failed to do that. Fmod say they want this strange sample rate, but it cannot do this, so it will use the phone's rate. But actually, the phone's rate is the correct answer. But Unity is so want to do this. Unity really want to use this number, but it cannot do that. So it try to instantiate with this number. And then a while after, it say, it cannot instantiate anyway, so you will play with no sound. But it's good thing that Unity does not really crash, but you have no sound because everything runs out. But good news, because if you use Unity Alpha. So Unity team just open the Alpha, not beta. In Alpha, you get the new feature immediately. But when that new feature has been tested, it is sent to beta next. So look at this patch note. It says Android will use OpenSSL instead of this audio track, Java. This one is C++, remember? On more devices. So what is this? I have a talk with Unity team in the forum again. So he finally say what is the criteria for the old one before this patch. So Unity, one of the criteria is that flag, the low latency flag and pro audio flag. If it is false, then immediately it uses Java. And this phone, it has both as false, but actually the performance is very good, this phone. But because the manufacturer, Xiaomi, forgot to set the flag somehow, so Unity choose Java, and then we get very slow payback. While in non-Unity game, it is fine. But after upgrading to this version and compile the game to the same phone, then you get fast track this time, because it does something to the condition. Okay. The condition right now after this version is that if the native buffer size is lower than 192 or equal, then it will try to use OpenSSL, regardless of the fast track. If it is false, it will not care. It will try to use OpenSSL. Then finally, your phone start up with your game in the same thread. You can see F, and then this is Unity game This is your phone. The rate is correct now. And then this is fast, of course. I'm happy. So please try this version if you want to get fast track on many Chinese phones, because apparently many Chinese phones report false flag, but actually has buffer size exactly 192. If it is like that, then you get fast track. I have tested also. So the same test, but the orange one is after I upgrade. You can see the gain here from this to this. From I measure it again like 400, now 200. So you get, this is the work of fast track. This is the work of Unity mixer. If you want to use mixer, then you must put up with this latency. But if you use completely native way of playing mid-frame, no mixer, nothing, just play one audio to one track, then you get this latency from this phone. Okay, so this is the cost of your latency, which has been fixed in the latest alpha, because you use bad audio track. I have been researching about latency numbers. I have seen some phone with some phone like this, with audio source Unity and native audio differing for very small number. This means this phone already get fast track, but this small difference is the Unity mixer and Fmod mixer. But some phone with extreme number like this likely get normal track. And I have talked with some Japanese developers. They say all Samsung Galaxy Note will get normal track because something. But because Samsung, majority of players have Samsung, so they will complain your game so slow. I don't know what is not fun, and give you 1 star. So you can upgrade to the latest beta to fix the problem of our Samsung. And then this is also my phone, Xiaomi. Also, not just that, the buffer size. It is exactly the latency, because the buffer size will hold your audio. If it is small, then it will read frequently, quickly. You put something in, it will put out on the audio, on the speaker. If the buffer size is large, then you spend time putting things on the space, and then when it is full, it puts out. Cheaper phone will have big buffer, but smaller phone will have smaller buffer. But you can set this in Unity by this option. So base latency, the question is, how large is the base latency? This is also one of the problems, because if the buffer is too small for the device to handle, then buffer underrun. It means it runs out of things to do. And then it plays some gibberish sound, like very scary sound, when the buffer underrun happens. The problem is if you export a plain Unity project with base latency and then play it with your PC, then the buffer is too small, like 100% of time. I don't know why, but Unity does not choose the buffer large enough. It's too small. For PC builds, you have to use good latency. But base latency is okay on Mac OS X, and then mostly okay on Android. In the remaining time, I will show you the buffer underrun. Okay, this is on a Mac, obviously. So just play audio. This is normal music. You have to remember. Okay, next one is from Windows. I have recorded from Windows. You can see it slow down. You can hear it slow down. Sorry. Like it stretch out when the buffer underrun happen, it is like that. If you use best latency, then this will happen 100%. I don't know why, but it is not on this Mac either. At first, I guess it overestimates your Mac ability to play, and then it use very small buffer. But I have sent this project to other PC user, and also same thing happens. So you have to be very careful. On Android, if you use best latency, mostly it is fine. Unity choose a good buffer size, but I know some case that it does not went well. So it is from this. You can hear the buffer underrun. The sound you hear is music, previously music, but now it cannot play the music. You can see the effect sound when the character jump. It sounds normal because he used the native audio on jumping sound. It does not go through Unity, but the background sound goes through Unity. Yeah, so this developer want to speed up only the response sound. So he do native approach only on response sound. So, and you can see the buffer underrun is by Unity choosing wrong buffer size. But the native plugin choose a buffer size that is correct, so it's normal. Okay, we got a little bit more time. So I will talk about A audio. Revolutionary. So A audio is trying to deprecate OpenSSL, but the catch is you have to be audio, Android audio or higher. So you cannot just do this, and then Nougat player, you cannot play your game. So if you want to use A audio to get even lower latency, then you have to if and still have your OpenSSL to have everyone get fast sound. But A audio can place your audio very close to the driver, so that's why it is better. But it is a hassle right now because Android user is not fast on upgrading the phone. Everyone is still on Nougat, or maybe the manufacturer don't want you to upgrade. Then they are stuck with Nougat and then cannot use A audio. But there is one more solution, that is Oboe by Google. This is GitHub. So Oboe will do what I just said. It puts an if, and if you got if you got audio, then it use A audio. If you got something lower than that, then it use OpenSSL. So perfect. If you want to do native audio, then you should try Oboe. So everyone can have fast sound. All right, I think that's it. So thank you for listening.